Bismillahirrahmanirrahim. Assalamu alaikum. I'm your host Rana Muhammad Kashif and you are watching my channel Positive People Commission. And welcome to introduction to our programming series. This is episode number 9. And what we learned in the episode number 8, we learned how to do logical operations in R. Many of the questions in this lesson were involved evaluating logical expressions and logical operators, etc. For that, you can also visit my R programming playlist on my channel where you will find this episode number 8. And what is episode number 9 is about? Episode number 9 of today will cover writing functions in R. You will also learn how to create your very first function in R. And again, this R course series is inspired by a swirl package in R. You can also learn R within R by just installing swirl package in R. So let's move to our R studio. And if you have worked through any other episodes of this free R course, you have probably used some functions already. Functions are usually characterized by the name of the function followed by parentheses. Let's try using a few basic functions just for fun. The system date, if you want to know the system date, just write sys.date tab and just enter. It will give you the today's date, and it represents a string representing today's date. Most functions in R return a value. Functions like this one, system.date, return a value based on your computer's environment, while other functions manipulate input data in order to compute a return value. For now, we will use the mean function. What mean function does? Mean function actually takes a vector of numbers as input and returns the average of all the numbers in the input vector. Inputs to function are often called arguments, and providing arguments to a function is also sometimes called passing arguments to that function. Arguments you want to pass to a function go inside the function's parentheses. So now let's try to get mean of a vector. For example, mean of a vector c 2 4 and 5. It will return average of these three numbers. Function usually take arguments which are variables that the function operates on. For example, the mean function takes a vector as an argument, like in the case this 2 4 5. The mean function then adds up all the numbers in the vector and divide it by the length of the vector. If I just do sum of c2 4 and 5 and divide it by length of c, again repeat that vector 2 4 5, it will give me the same result. So that actually mean function does. That was just a brief introduction. Now let's write our first function in R. A very simple function. Let's name it as my underscore function and function of x, and just simply give it as x. Now that we have created our first function, let's test it. If I type my underscore function and just pass this argument, my first function, it will give me the same output. By writing functions, you can gain serious insights into how R actually works. If you want to see the source code of any function, just type the function name without any arguments or parentheses. Let's try this out with the function we just created. Type my underscore function without parentheses, and it will give me the source code of its function, which is my underscore function. Now time to make a more useful function. We are going to replicate the functionality of the mean function by creating a function called my underscore mean. We will be creating our own function of mean. Remember that to calculate the average of all the numbers in a vector, you find the sum of all the numbers in the vector and then divide that sum by the number of the numbers in the vector. How we can do this? We first need to understand two functions. The first one is sum function. What sum function does, that sum function actually what sum function does that it returns the sum of a vector and what length function does, length function actually it does that it gives the size of a vector. And now let's create our function my underscore mean function of, it will have a argument my underscore vector curly braces and sum of my underscore vector divided by length of my underscore vector. We have just created our own function for the mean. Now test our my underscore mean function by finding the mean of the same vector we did previously here. And now my underscore mean and pass on a vector 2 4 5. You see it gives the same output. So that's how we can define our own function. That was just an example to establish a comparison, but recommendation is that you must use the predefined function if there is already a function. If there is not a function, you can create your own at any time. Now a little test. Next, let's try writing a function with default arguments. We can set default values for a function arguments, and this can be useful if we think someone who uses our function will set a certain argument to the same value most of the time. We are going to write a function called remainder in which we will in which remainder will take two arguments, number and divisor, where number is divided by the divisor and the remainder is returned. Imagine that we usually want to know the remainder when we divide it by 2. So set the default value of the divisor to 2. Be sure that number is the first argument and divisor is the second argument. Now let's just do it. Enough of details. We can use the modulus operator to find the remainder. For example, if I want to find remainder of 7 divided by 4, I can use modulus operator and it will give me 3. So let's do it. Create a function of remainder function of number and divisor. It will be a simple function. Imagine that you usually want to know the remainder when you divide by 2. So set the default value of divisor to 2, and we can do it as divisor equal to 2. And what argument we will pass? We just number divided by divisor, number modulus operator divisor. Press enter. We have just created our own function. Let's do some testing. If I write remainder of 5 only, if I pass on it, just 5 divided by 2 because we have set divisor to a default value of 2. Now let's take a moment to examine what just happened. We provided one argument to the function and R matched that argument to num, since num is the first argument. The default value for divisor is 2, so the function used the default value we provided. Now let's test the remainder function by providing two arguments. Type remainder of 11 and 5, and let's see what happens. It gives me 1, and once again the arguments have been matched appropriately. We can also explicitly specify arguments in a function. When we explicitly designate argument values by name, the ordering of the arguments becomes unimportant. We can try out this by remainder of, if I write divisor first as 11 and num is equal to 5, it gives me 5. As you can see, there is a significant difference between remainder 11 5 and remainder we just did here. Arg and also partially match arguments. Now let's try typing remainder 4, and instead of writing complete we just write div equal to 2 to see this feature in action. So that's how it works as well. But there is a word of warning. In general, you want to make your code as easy to understand as possible. Switching around the orders of arguments by specifying their names or only using partial arguments names can be confusing. So use these features with caution. With all of this talk about arguments, you may be wondering if there is a way you can see a function's arguments beside looking at the documentation. Thankfully, you can use the args function. Let's type args of the remainder function we just have created. Sorry, remainder, and it gives me the arguments of this function. You may not realize it, but I just tricked you into doing something pretty interesting. Arguments is a function, args is a function, remainder is a function, yet remainder was an argument for the args function. Yes, it's true, you can pass functions as arguments. This is a very powerful concept. The idea of passing functions as arguments to other functions is an important and fundamental concept in R programming. For the rest of this episode we are going to use the paste function frequently. So just what is the paste function? If I just go on to help and press paste, and if I just open it up, as we can see, the first argument of the paste function is which is referred to as an ellipsis or simply dot dot dot. The ellipsis allows us an indefinite number of arguments to be passed into a function. In the case of paste, any number of strings can be passed as arguments, and paste will return all of the strings combined into one string. Now let's just to see how paste works. Let us just type paste programming is fun. Just time to write our own modified version of paste now. Let's do something different. Telegrams used to be peppered with the word start and stop in order to demarcate the beginning and the end of the sentences. Now let's write a function below called telegram that format the sentences like this. Telegram is a function where paste start is the first argument is start, the second one argument we can input, and the stop and the separator. And if I run telegram of let's say good morning again, and it start good morning and then it stops. Well, we are coming to the end of this lesson, but there is still one more idea that you should be made aware of. You must be familiar with adding, subtracting, multiplying, and dividing numbers in R. To do this, we have already used the plus, minus, asterisk for multiplication and division symbols. These symbols are called binary operators because they take two inputs, and input from the left and input from the right. In R, you can define your own binary operators as well. In the next, I will show you how. The syntax for creating new binary operators in R is very unlike anything else in R, but it allows you to define a new syntax for your function. I would only recommend making your own binary operators if you plan on using it regularly. User-defined binary operators have the following syntax. For example, if I write this like this, whatever, and close it again, where whatever represents any valid variable name, it is actually a syntax to write our own binary function. Now let's do it practically. write our own binary operators below from the absolute scratch. Our binary operator must be called p and function of left and right, where paste two arguments left right, just paste left and right. So we made our own binary operator. Let's test it out. Paste together the string I love R using our own binary operators. So how we will do? I our function p we just created, sorry, small p love, again pass on the function R. If I press enter, it will give me the output I love R. That's how we can create our or binary of function in R. So coming to the conclusion of this episode, we have come to the end of our episode. And now go out there and write some great functions of your own. In this lesson we covered how to write our functions in R and how are some basics of the functions in R. So what's coming up with the next episode, number 10 of the introduction to R programming series. In the next episode we will cover very important functions in R, which is lapply and sapply. In this lesson we will learn how to use lapply and sapply, the two most important members of the rsapply family functions, and also known as loop functions. More about this in the next episode. Till then, take care. Allah Hafiz. Bye bye.